The next thing we looked at is beam finish. When you go back to the architectural design, this is the first to third floor plan. When you look at the architectural design, you obviously know that on the roof level we would have some parapets. You know, once we cast the slab, there will be some finishes that will be applied over the beam, over the beams. Okay, you cast the slab, you might screed, and then you can apply the felting that is to be applied and some other finishes. The client might decide to also apply some 1-inch thick tiles and so on. So finishes associated with these, you need to calculate and estimate these loads and apply it on your structure. So we apply 1 kilonewton per meter to cater for beam finishes, and we apply it on the entire beams. Then the roof imposed load transferred to the beams. So we have transferred the dead load from the roof slab to the roof beams. We now have transferred the imposed load from the roof slab to the roof beams. Please note carefully that the roof dead load, which we have computed here in our analysis, is typically the weight of the roof slab. There is also associated roof dead load. There is also roof dead load associated with the roofing sheet material, which is the timber trusses, which comprises of the pole lines, timber pole lines, as you can see on your screen, the rafter struts, the rafter tie beams, okay, that make up the roof trusses. All of these loads can be taken as 0 point. So roof truss dead load from structural assessment would vary between 0.1 and 0.3 kilonewton per meter square. Roof truss imposed load, which is load associated with human access in the event of any form of maintenance on the roof, we have applied that already as 0.75, which is maintenance access on the roof. But roof truss dead load was omitted in this our analysis because we had felt it is insignificant as compared to the self weight of the concrete slab. So pay very close attention that in some analysis you may have to also include the roof truss dead load. Okay, and the roof trusses is made up of hardwood. So you have your upper cord, lower cord. So this is a mono-pitched truss arrangement. You can see it slopes in this direction and slope. So you have dual mono-pitch truss arrangement, and the truss will comprise of the rafter, to comprise of the pole lines that carry the roofing sheets, and then it will also comprise of the struts and tie, okay, which are the roof truss members. All of the loads together from detailed analysis will not exceed 0.3 kilonewton per meter square. So 0.3 kilonewton per meter square, you know, is negligible as compared to what we have computed here. So the factor of safety against dead loads, the factor of safety applied to dead loads, we cater for any form of load variation. So we haven't applied the roof truss dead load. So in some cases you will have to calculate that as well too. But because the roof is slabbed, we felt the roof slab has significant loads as compared to the roof truss, which is quite insignificant. So that would have comprised the dead load on the roof. We may also choose to add it as part of the roof slab dead load. We are going to do that now. Let's add the roof truss dead load as part of the roof slab dead load. So we are taking the roof truss dead load as 0.3 kilonewton per meter square. So we use floor load mechanism. So we say as before, let's look at where the roof truss is framing. So it slopes here and then here and slopes. So you have the roof truss all around the roofing area. Okay, so this is the roof slab layout, structural layout, and then this is the roofing layout. The roofing layout is overlapping the roof truss structural layout. We have created an overlap to see the location of the roof trusses. So you can see that the roof trusses completely occupy the entire roof slab except at this void. So let's look at this void clearly. Okay, so it also occupies this voided location. So this voided location do not have slab. It's only the absence of a slab that exists at this void location. So it means that this is a very crucial observation. So if you go back to your roof load, you would see that we have applied, if you go back to your slab dead load, you will see that you have applied slab dead load over the voided area. So this is wrong. You see the reason why you need to go back and do quality assurance, due diligence check on your analysis model. So we are going to change this configuration to ensure that it doesn't transfer slab load from this region. So it will transfer slab load only from here to there. If you want to see only the regions associated with this definition which you have done, right click on label, click on display floor loading. Good. You will see the regions that have been covered, the area that has been covered by this definition. You see that you have this area, this boundary point has been covered by this definition, causing STAAD to think that there is a slab here and transferring the tributary slab load onto this beam, which is wrong. So we're going to redefine these regions. We are going to break it down into a region that will terminate somewhere here, and then we'll define these other regions separately, and then we'll define these other regions separately, so that it transfers the load from this slab to the beam, that slab to the, but it will note carefully that there is no slab here, that this is a void. Let's see how that is done. Okay, come and edit this location. Go to edit. The x coordinate here is -1, that's correct. The x coordinate here is 10.648. The z coordinate here is 10.277. And then the z coordinate here is 10, which is correct, so change. Good. Great. So we're going to also define, let's define this location. Okay, so you go back here, roof slab dead load, add floor load, dead load minus 2.5, y is 14.9, x is 7.455, x is 19.780, and then z is 2.825, and then maximum z here is 10.277. Okay, let's see. Great. Perfect. This is beautiful. So it has covered this location. So I need to now Okay, so this is another panel. I need to define this panel separately, then define this panel, and then define this panel. Okay, so that you don't create duplicate loadings. It's very important that you do not duplicate loads or load the beams wrongly. So the panels has to be defined carefully and correctly, meticulously. So I'm going to define this other panel now. Come back here again, roof slab, floor load minus 2.5, which is the dead load. So I want to define this region now. So what's the y coordinates? 14.9. X 16.587, 19.78. Z is -1, 4.251. Now let's define. I've defined here Z is